Assalamu alaikum, dear students. I am coming again with the same topic. That topic is distance and displacement. I am continuing this, and that is part second of distance and displacement. And I am going to continue the same topic. Hope you will listen to me. See, my dear students. Again, writing here, my dear students. I am writing here distance, and I am writing here displacement. And already I discussed that distance is the actual path length. Recap of the last lecture, it is actual path length. And dear students, first point here, but it is the shortest path. Already told about you about this thing, distance and displacement. It is actual path length and it is the shortest path. And number 2 point, it is a scalar. That is, distance is a scalar quantity, but dear students, this displacement is a vector quantity. I am writing this thing here, dear students. It is a vector quantity. Now the third point that I am going to write here is distance may be positive or zero, but it is never negative. Please write down these things. These are very important. Now, what I have written here, distance is positive, or dear students, it may be zero, but it is never negative. But displacement, it may be positive, dear students, it may be negative, or even it may be zero. Now, dear students, I will illustrate this thing with the help of an example. See, my dear students, I am taking here an example to illustrate this thing. Let us take a number line, and in this number line, dear students, I am taking here a point O, and let towards the right I am taking here to be as positive. Like in beta, I am taking negative direction towards left. It is by convenience. I am writing towards to be as positive and left towards to be as negative. You can either write left to be as positive, right to be as negative, no problem at all. But usually we write right to be as positive and left to be as negative. Suppose a body starts from point O, and after a certain interval of time it reaches to point A, covering a distance of 5 meters. This 5 is here length, and length is always positive because distance is a scalar quantity. So this particle is in motion. When it is in motion, it covers a distance of 5, that is positive. For a moving particle, here distance, dear students, here displacement. For a moving particle, distance is positive. Distance is positive, but when the particle is in motion. For a moving particle, when a particle is in motion, the distance is always positive. But when in most of the books it is written that distance is positive, never negative, never zero. But distance may be even zero, as when we deal with the numericals, when we discuss numericals, then you will see that even distance may be zero. When distance is zero for a particle which is at rest. Very easy, no problem at all. Distance is positive for a particle which is in motion because it is length, and length is never negative, it is always positive. Here negative positive in the displacement is direction. So it is zero, distance may be zero, but for a particle which is at rest. But it is never negative because here this displacement may be positive, it may be negative, or even zero. How? See, my dear students, let us this particle move towards right. If we take into account of direction, then it is moving towards the right direction, and we take OA vector to be as plus 5m. Plus 5m means that is direction is towards right, and 5 means magnitude, and magnitude of a vector quantity is always positive, but it is the direction is given by positive or negative. So here positive means it is towards right, that is towards here east, but 5 is magnitude, and magnitude of a vector quantity is always positive. So here displacement may be positive. Now when displacement is negative, it is very easy. If the particle is moving towards the left, suppose it moves again 5 meters, but now it is moving towards the left. When we are talking about displacement, then we have to write here, let us, this is OA dash, vector OA dash here is equal to minus 5m. This minus 5 means that this is because displacement has both magnitude as well as direction. That is why I am writing here minus minus indicates that it is moving towards the left, and 5 is magnitude. Magnitude is always positive, but it is just negative here indicates direction. So my dear students, displacement may be positive or it may be negative. Now how it is 0? It is very clear. See my dear students, again taking the number line, let us take here origin, let the body moves towards right, and let us take there to be as positive and this left to be as negative. Suppose the body is starting from point O, and after a certain interval of time it reaches to point A covering a distance of 5 meters. See my dear, when I am talking about the displacement, then you have to take here positive. Positive means the direction is towards right. By the way, if it is moving here, it is returning here. This point is known as returning point, and here the body comes at rest. So we take V to be as 0. We will discuss about the speed and velocity later on, but for here you have to remember when any particle comes to rest, at that time velocity or speed is 0. It comes back from A to O covering the same distance. Now I have to write, when I am talking about displacement, minus 5. So what is the total displacement during from O to A, then from A to O is, my dear students, that is O to A, then from A to O is 0. Why it is 0, dear students? It is clear, because total displacement we have to add it according to the laws of vectors. So my dear students, I have to write plus 5m and minus 5m because proper sign due to direction, and this gets cancelled. Those, therefore here displacement is 0. What does it mean? If a particle starts from any position, then after a certain interval of time it comes back to the same position, then at that time, during that interval of time, the displacement of the particle is 0. So you have got this. Displacement may be positive, it may be negative, or it may be 0, but distance is always positive or 0, never negative. Hope you have got this point. Now proceeding to the next point here. Here it is distance, and here it is, dear students, displacement. See my dear students, now the fourth point, very important point. This point is also very important. See my dear, the magnitude of distance is always greater than or equal to the magnitude of displacement. So I can write here, magnitude of displacement is always less than or equal to magnitude of distance. Same thing. I am writing here left to right and left to right, but changing the sign. How this is? See my dear, very easy to explain this thing. Let us, I am taking again a point A here and here a point B. If a body is traveling along this path, let us, this path is L1, let the length of the path is 8 meters. Now suppose the body in the second case moves from point A to point B covering a length of 3 meters. See my dear students, but this shortest path is also here displacement. Now I am talking about the magnitude. Here magnitude of this length is 8, but here the magnitude of this path is 3. If the body moves along this path, then at that time distance is, that is just 8 is greater than 3. This is nothing but this is the magnitude of distance, and this is the magnitude of displacement at that time. But if the body travels, in the second case, if it travels along the straight line, then at that time the magnitude of distance, that is actual path, is equal to the magnitude of the displacement. So combining first and second, we can write the distance may be greater than or equal to displacement, magnitude of displacement. If it travels along the same path, then magnitude of distance is equal to magnitude of displacement. But if it travels along different paths, then at that time magnitude of distance is greater than the magnitude of displacement. I hope you have got this point, and that point is very, very important. Now I am proceeding to the next point, and next point is like this here. See, my dear, the fifth point is like this. Distance always increases with time, always increases with respect to time. With respect to time. But dear students, displacement may increase or decrease with respect to time. Arrow indicators here, upward arrow means increase, here I am taking downward to be as decrease, here I am taking upward to be as increase. Distance always increases, dear students, with respect to time, but so far as displacement is concerned, it may increase or it may decrease with respect to time. Now the question arises, sir, please explain it. So dear students, note this and keep attention here, how this increases and how this increases and then decreases with respect to time. I will illustrate this thing taking an example, so as to have clarity about this thing. See, my dear students, what I will do here, suppose I am taking here ground, and at ground level I am projecting a body like upwards, giving some initial velocity. Let initial velocity given is u, and after a certain interval of time it will reach the highest point, then after that it will return back. But at the highest point, its speed or velocity becomes zero, because the particle at the highest point, let's take this highest point to be as a, at this point v becomes zero. And when it then moves downwards, when it travels downwards, when this journey is downwards, after that finally it comes to back to its original position. See, my dear students, one thing, when it goes from initial to final, then from final to initial, here during this time interval, when it comes back to the same position, it is clear now the displacement is zero. Now, but my question is how distance increases, but displacement may increase as well as decrease. Let us take this interval from O to, let us consider this to be as O point, from O to A, when time is, there is time, time increases. With the increase in time, the distance increases, because distance is the actual path. Also the displacement increases, because the shortest path here, that is the path between these 2 points, with respect to time, it increases. In this interval, both distance as well as displacement increases up to point A. But after point A, when it goes downwards, distance continuously increases. Distance continuously increases because distance is the actual path length. But when suppose it reaches point A dash here, at that time the displacement is from initial to the final position, and that decreases. And when it moves more and more towards the ground, again distance increases, but finally displacement decreases and reaches to zero. So it is clear from this diagram that distance as well as distance increases with respect to time, because it is the actual path, but displacement is from initial to final. It decreases, but it decreases when here from the top point it goes downwards. I think you have got this point. I will illustrate this thing by taking another example. Suppose a particle is starting from point O and goes towards point A. When time, there is increase in time, it is a function of time means. So here when body moves from point O to A, distance increases and displacement increases. But when it returns, this is a returning point. At this point, v is equal to 0. When it comes back, here now, distance again increases. Distance increases because distance is the actual path. But now here, displacement is initial to final position. That starts decreasing. But during the interval, when the body goes from point A to point O, hope you have got this question. You have got this point. This point is very useful when we deal with the numericals related with the equations of motion. And I have seen so many questions that have been posed there in the competitive exams, particularly in NEET and JEE, related to these concepts. And with this, my dear students, I am now proceeding towards the last point of this distance and displacement. See, my dear, if I am taking here distance, dear students, and I am taking here displacement, distance, now the sixth point, distance tells us the actual path traveled by a body between two points, but displacement does not tell us about the actual path traveled by a body between two points because it is the shortest distance, whether the body travels through that distance or not, but distance is the actual path traveled by a body between two points. Thus, it tells us about the path followed. Please write down this, my dear students. That is very, very important, although it seems to be as easy, but later on when we deal with the numericals, this happens to be very crucial and critical here. And I am writing here sixth point. It does not tell us anything. It does not tell us anything about the path followed. It does not tell us anything about the path followed. Hope you have got this point. Now, my dear students, I am proceeding toward the simple numericals that will again give the clarity between the distance and displacement, and meantime differentiates distance from displacement. See, dear, numericals, but very, very simple here. Simple numericals. Suppose, dear students, let us take this as a point O and this as x-axis, and my dear students, this has to be y-axis. This is origin, and origin is that point where we take observations. Suppose a body starts from this point, and after a certain interval of time, it reaches to point A, covering a distance of 4 meters. And then after time t, when it reaches to point A, it turns towards the left. This is left side, but here it is upwards, and upward direction is north. As we know, this is east. This is, dear students, west, and here it is south, and the upward direction is taken to be as north. Suppose it goes towards north, covering a distance of 3 meters, and finally reaches to the point B. Then question, if this is the case, then find distance. Then find distance between O and B, and displacement between O and B. This is the question here. A body starts from point O and reaches to point A, travels a distance of 4 meters, then goes from A to B, covers a distance of 3 meters towards north. During this motion, we had to find displacement from O to B and distance from O to B. Since distance is a scalar quantity, for this we have to find only magnitude, but for displacement we have to find magnitude as well as direction. This thing you should keep in mind. So, dear students, see how I can solve this question. This is very, very easy, but there is a lot of significance behind this question. See, my dear. Solution here. So distance from O to B is simple because the actual path that it travels from O to A then goes from A to B. So distance from O to B. Distance from O to B is nothing but it is 4m, simple addition because it is a scalar quantity. These are added just like real numbers. 3m, and that gives us 7m. So it is very easy. Distance is 4m plus 7m. But the question arises now, what is the displacement between points O and B? And we know from the definition it is the shortest path where the body has traveled or not. Concept based. Now see dear students, displacement. First of all, I will here find displacement both in magnitude as well as direction. Then analytical approach, I will separate its direction from its magnitude, and I will separately find its magnitude and separately find its direction, and that is known as analysis, that is known as analytical approach. See my dear students, it is clear OB vector is equal to OA vector plus OA vector plus AB vector, because when two vectors are representing two sides of a triangle taken in the same order, then their resultant is given by the third side of the triangle but taken in opposite order. But dear students, OA is equal to, magnitude is having 4 but direction is towards east, and that direction is towards x-axis. The direction along x-axis is shown by a unit vector, and that unit vector is represented by I cap. So I can write here as I cap. When the unit vector is multiplied with the magnitude, it gives the vector here, and this vector contains both magnitude as well as direction, and magnitude is 4 separate and its direction is along x-axis, that is denoted by I cap. Plus AB here, AB is equal to 3, magnitude is 3 but its direction is towards y-axis, and that direction is denoted by J cap. Hope you have got this question. So in this OB, it contains both magnitude as well as direction. Now I will separately find its magnitude and separately its direction. That is the question here. Now it is clear magnitude of vector OB is given by under root of, I am taking the coefficient of I and taking it as square here. This is rule. This, as I have already done such questions. We have discussed these questions here in the vectors, and now J cap has here coefficient 3, taking it to square, and it is clear 4 4s are 16 plus 3 3s are 19, and that comes out to be as 25, and that comes out to be as 5. So what is the length of, magnitude means length of this vector is 5 meter, and I think you have got this point. Now we have to find the direction of this OB vector. That means how much angle it is forming with the direction of x-axis, and that angle will give us the direction of this OB vector with respect to x-axis. It is clear now, dear students. In right angular triangle, direction of OB vector, how we can calculate this? We can calculate this like this. In right angle triangle, my dear students, OAB, it is clear now. See my dear students, that tan theta is equal to perpendicular by base, because the angle opposite to theta is perpendicular and adjacent to is base. So I am writing 3/4. Now I had to find here theta. It is very easy, my dear students. See my dear students, remember this triangle, a beautiful triangle that I will write here, and remember it forever, and it will help you in solving so many numericals. If here angle is 37 and here angle is 90, it is clear, right angular triangle, and obviously it is 53. हमेशा के लिए बेटा याद रखो कि 37 के अपोजिट जो भी, ये याद रखो कि 3 लेना है बेटा, और 53 के अपोजिट क्योंकि ये थोड़ा बड़ा है तो 4 लेना है यहाँ. Or, and I take this side to be then by Pythagoras theorem, it comes out to be as 5. This triangle is a very, very beautiful triangle, and remember this triangle forever. It will help you to solve so many numericals there in future. See, my dear, now it is clear, here is 3, here is 4, and here is 5. So theta must be 37. Therefore, when tan theta is 3 by 4, it means here theta 3 by 4, theta is 37. Hope you have got this question. Now, thus the direction of OB is at an angle of 30 degree, with x-axis. Thus, I have calculated its magnitude as well as direction. Hope you have got this question, and I am proceeding to the next problem. And next problem is very easy, and that I can explain like this. See, my dear students, simple problems but very important. Second problem here, second numerical. Here I am taking a point O, and this is R, and let a particle is revolving like this. R is the radius of the circle. Let's say particle starts from point A, and after a certain interval of time it reaches to point B, making an angle. The particle is revolving around the circle. The particle is revolving in a circle in anti-clockwise direction. Let the particle starts from point A, and after a certain interval of time it reaches to point B. We have to find here. The question here is find AB, but length of the arc, and that length of the arc is nothing but, dear students, that is distance. And find second thing, find displacement, that is AB vector, that is displacement. Displacement is nothing but, dear students, it is the shortest distance between points A and B. So what is the question? Question is, when the particle travels from point A to B, find distance, that is actual path, and find displacement, that is the shortest path between points A and B. So how I can calculate this? It is very easy, my dear. See, my dear students, now I am taking here solution, writing it a solution. Please write down these things. These are very beautiful. These are very important so far as NEET and JEE is concerned. See, my dear students, let this arc makes an, it is also given, dear students, that this arc makes an angle theta is equal to 90 at the center of the circle. It is also given, my dear students, for your kind information. Now, see, my dear students, solution is like this. It is clear that this theta is equal to L by R, because the definition of this angle is that it is the length of the arc divided by radius. Now I have to calculate L here, because this L is nothing. This L is the magnitude of distance from point A to B. See, dear students, please keep attention here. So L comes on L, and it is nothing but it is R theta. But theta, when you take circular motion, then at the time you have to convert degrees into radians. Keep this in mind. That is very important. These things we have already done there in the chapter units and measurements. So, my dear students, L is equal to R theta. Here theta is equal to 90, but 90 degree is equal to pi by 2 radian. So I am writing here this theta to be as pi by 2. Therefore, L is equal to, L is nothing but that is the length of the arc AB, and length of the arc AB is nothing, that is distance. So distance comes out to be as pi R by 2. Hope you have got this point. That is very easy. I can calculate this by this method also. See, my dear students, it depends upon you. If the total length of this circle, that is circumference of the circle, is 2 pi R, then the length AB is, length of the arc is, because this length of the arc is 1/4 of the circumference of the circle, so I can divide here by 4. That is another way to find this. 2 1s are 2, 2 2s are 4, so I am writing here pi R by 2. Hope you have got this point. Now the question is, the most important point here is how we can find here displacement. That's very important, dear students. See, my dear, one way to find is easy but is not ideal. AB in right angle triangle, in right angle triangle AOB. This is hypotenuse, this is base, and this is perpendicular. This is again radius, because the magnitude of this length is R, the magnitude of this OB is R. सो आई एम राइटिंग हियर दिस, बेटा मैं ऐसे लिखूंगा कि हाइपोटेन्यूज स्क्वायर होता है बेस स्क्वायर प्लस परपेंडिकुलर स्क्वायर, तो मैं लिखूंगा यहाँ आर स्क्वायर प्लस आर स्क्वायर ए बी स्क्वायर, ए बी स्क्वायर इज इक्वल टू आर स्क्वायर प्लस आर स्क्वायर, बट आर स्क्वायर प्लस आर स्क्वायर इज इक्वल टू 2r स्क्वायर, here it is ab square, but when I am taking ab, बेटा जब ab लूंगा तो यहाँ स्क्वायर रूट हो जाएगा अंडर रूट 2r स्क्वायर, but dear students here I am writing under root 2 because square and r gets cancelled, so it is under root 2r. But that is not ideal way to find that this is magnitude of displacement. This is magnitude of, keep this thing because I am writing length. Length of the vector is the magnitude. Length of the vector here is AB and that is here under root 2r. See my dear? Thus I have find now how I can find here direction of AB. Another way to find is like this. That is a very beautiful, that is ideal way to find displacement. See my dear, let's take this center to be as origin, that is observing point. Therefore this OA point at that time is position vector of point A, because when a point is joined to the origin and direction towards that point, that is position vector. And let this is R2 means position vector of point B with respect to O. But the magnitude of R1 is again R and magnitude of R2 is again R. I can write this thing like this, R1 vector. First of all, R1 vector is not equal to R2 vector. Beta why? क्या reason है? Reason क्या है? क्यों R1 vector क्यों नहीं बराबर है R2 के बराबर? क्योंकि बेटा दोनों की मैग्नीट्यूड सेम है, लेकिन डायरेक्शन R1 की डायरेक्शन यहाँ, लेकिन R2 की डायरेक्शन यहाँ. Because these are displacement vectors. These can be differentiated. They are not equal. Why they are not equal? Because reason बेटा ये है कि डायरेक्शन डिफरेंट है. All the magnitude have same. I can write, but magnitude of R1 vector is equal to magnitude of R2 vector. और दोनों का बेटा है same because they are radii of the same circle. Now dear students, how I can write this displacement vector? Because if I am taking this to be as x-axis and my dear students I am taking this to be as y-axis, then it is clear this AB is nothing. This AB is displacement vector because there is the change in position of the particle from point A to B in a given interval of time, and that change in position vector that is final minus initial will give us AB vector. So therefore we know AB vector is equal to R2 vector minus R1 vector, because this is initial vector, position vector, this is final position vector. Displacement is defined as the change in position vector. So I can write R2 to be as the magnitude of R2 is R, but its direction is along y-axis and that is denoted by J cap. So I am writing here J cap minus the R1, its magnitude is again R, but its direction is towards x-axis. तो बेटा इसकी direction कहाँ है? x-axis की तरफ है. तो बेटा यहाँ लिखूंगा this is AB vector. So here in this AB contains together, jointly together, both magnitude as well as direction. But I have to write its direction separately. I have to give it its magnitude separately, and that is known as analysis of this vector. Analytical approach of this vector to write separately its magnitude and separately its direction. See dear students, तो इसका मैग्नीट्यूड बेटा कैसे आएगा? तो ऐसे लिखूंगा मैग्नीट्यूड ऐसे लिखते हैं, तो ये आएगा अंडर रूट, इस j का कोफिशिएंट है यहाँ r, इसका स्क्वायर प्लस और बेटा इस i का यहाँ स्क्वायर माइनस r और यहाँ लिखेंगे स्क्वायर. तो बेटा ये आएगा r स्क्वायर प्लस माइनस r का होल स्क्वायर, ये भी आएगा बेटा r स्क्वायर, तो r स्क्वायर प्लस r स्क्वायर इज इक्वल टू अंडर रूट 2r स्क्वायर, but that comes out to be as under root 2r. So thus it is the same as that in the first case, but that is the ideal way because this will help you, this will facilitate you in solving the numericals there in the chapters that we have to face when we deal with the dynamics or rotational dynamics or in fluid dynamics, etc. Because also this will help you in electrostatics. You will almost see these things in every branch of physics. So deal like this. This is the ideal way, although it happens to be as difficult. See here, so we have find the magnitude of AB, that comes out to be as root 2r. So I hope that you have got this point. Now the direction of, what is the direction of AB? See my dear students, what is the direction? Now direction of AB. this AB vector makes an angle, see my dear students, it is at an angle theta but makes with negative y-axis. See dear students, now tan theta here is again, it is dear students r by r, or this is perpendicular, this is base. So I can write r by r and r by r cancel it, here comes out to be as 1. So what is the direction of AB? The direction of AB is such that it makes an angle theta but with the negative direction of x-axis, with the negative direction of x-axis. Thus what angle it will form with the positive x-axis? It will form an angle of 180 minus theta, and that 180 minus theta means here. Now let us write this thing, tan theta here is equal to 1. So theta comes out because this side is equal to this magnitude. So it is here angle is 45. When it is 1, then this theta is equal to 45 because tan 45 is equal to 1. So if AB makes an angle 45 with this, so what angle it will make with this? It will make an angle of 180 minus 45, and that comes out to be as 135. So the direction of AB is such that it makes an angle of 135 with the x-axis. Hope you have got this point. Inshallah, I will meet you next time. Till to okay, may Allah bless you. Have a nice day ahead. Good luck to you, my dear students. Okay.